بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. This is section 8.1 arc length, and chapter 8 is about further applications of integration. And we would like to define here in this section how to find the length of an arc. So, for example, we have this blue arc. Well, we can approximate this arc by finding the length of this line that's connecting the two endpoints of the arc. Well, if you remember, the length of the line will be square root of change of x square, x2 minus x1 square, plus change of y square, y2 minus y1 square. If we divide the arc length into two portions, then the length of these two lines, the sum of the length, would be maybe more accurate, closer to the accurate length of the exact length of the arc. And if you keep dividing the arc length, the arc or the curve into small portions, then when you add the length of the lines, you will get a very nice approximate of the length of the arc. So if we call to find a formula for the arc length, let us call the distance ds. This the length of the line as ds, and the change in x is dx and the change in y is dy. Then from Pythagorean theorem, or even from the length of the line formula, we know that ds is square root of dx square plus dy square. Where ds is the length of this line. Now, I can take dx square as a common factor, and then I'll have 1 plus dy over dx, dy by dx to the power 2. And then I can write ds as square root of 1 plus dy by dx to the power 2 times the square root of dx square or dx. So this is a definition of ds. And if you take ds small portion of, as small as possible of the curve, then the tangent line to the curve with length ds would be very close to the actual length of the small arc. Now, if you take the sum of all of these ds's, then you will get the exact arc length. So the length of the curve would be integral of ds. So the length of the curve, we call it L, would be integral from a to b of ds, and ds as square root of 1 plus dy by dx, or you can write it f prime square dx. So this is the arc length when the integration is respect to x, and x is given from a to b, and here to find dy by dx, the function y has to be, or the equation has to be solved for y. Y is written as a function of x. So that's the formula of the arc length, and let us use it. Let us first use it here on this straight line. We know how to find the length of the line using the distance formula. So he says here in the question, use arc length to find the length of this curve, which is the line, from -1 to 3, and check your answer by noting that the curve is a line segment and calculating its length by the distance formula. So what are the coordinates of this point? Well, x, I can see that x is -1. But how to find the y coordinate? I just replace x by -1 here in the equation. or here because this is the equation of the line. So 3 minus 2 times negative 1, 3 plus 2 is 5. So this point has coordinates negative 1 and 5. And this point, the x coordinate is 3, clear, but the y coordinate will be 3 minus 2 times 3. So 3 negative 6, so minus 2. So this point has coordinates 3 and negative 2. Well, 3 minus 6 is negative 3, sorry. So negative 3. Now let us use the distance formula to find the length of the line. So negative 3 minus 5, that's negative 8. This is the change in y to the power 2, plus the change in x. 3 minus minus 1 is 4 to the power 2. Now this is 80, 64 plus 16 is 80. So it's square root of 80. And 80 is 16 times 5. And the square root of 16 is 4. So the distance between these 2 points, or the length of the line, is 4 square root of 5 using the distance formula. Now let us use the arc length formula, the new formula, which we have now. So to use this formula, I'll write first y as a function of x. So yeah, y is written as a function of x. Y is 3 minus 2x. And then I'll find dy by dx, or y prime. Well, y prime is negative 2. And then I find dy by dx square, which is y prime square. Well, y prime square would be negative 2 to the power 2, and that would be 4. And then L would be integral from x changes from negative 1 to 3, square root of 1 plus y prime square. So 1 plus 4, that's 5 dx. So the integration would be square root of 5 x, where x runs from 3 minus 1, or you can use the formula. We have a formula, square root of 5 times b minus a. 3 plus 1 is 4, so the integral is 4 equal to 4 square root of 5, which is also the same result we got it when we used the distance formula. So good, the arc length formula works here, and that's now we are somehow believing in this formula. Let us try another example, but now let us find the length of this arc, which is a portion of a circle. In fact, is it half a circle? No, it's a quarter of a circle, okay? So we can find the length of this arc, which is a quarter of a circle, by geometry. By geometry, check your answer by noting that the curve is a part of a circle, So geometry says that the circumference of the circle, okay, circumference of the circle is 2 pi r. But we don't have all the circle, we have c over 4, quarter of the circle. So, and r is 2. R is the radius. The radius of the circle is just 2. So 2 pi times 2 over 4. 2 times 2 is 4, cancels with 4. And pi would be the length of this arc. So the length of the arc should be pi, quarter of a circle. Well, this is using geometry. Let us find L now using the formula. So we know the formula, it is square root of x runs from 0 to 2, square root of 1 plus y prime square dx. So to use the formula, let me, y should be written as a function of x, and y is written as a function of x. So let us find y prime. So y prime is the derivative of the square root is 1 over 2 times the square root times the derivative of what is inside the square root. So the derivative is negative 2x. Now 2 cancels with 2, and I need y prime to the power 2. Y prime to the power 2 would be, if you raise this to the power 2, the negative x to the power 2 would be x squared over 4 minus x squared. When you raise the square root to the power 2, the square root will disappear. Okay, so this is y prime square. Now we need to find 1 plus y prime square. Okay, this is what is inside the root. So I need to add these two terms, fractions. And always we will need this formula, that a over b minus c over d equals to bd in the denominator, ad minus bc in the numerator. If there is a plus, it would come here. This formula becomes important in this section. We will need it always. So here, this is 1 over 1. So let us add. So we will have 4 minus x squared times 1, and also 4 minus x squared times 1, plus 1 times x squared. X squared cancels with x squared, and this would be 1 plus y prime square. So now L would be integral from 0 to 2, square root of 1 plus y prime square root of this. So it would be square root of 4 over 4 minus x squared dx. But I can distribute the square root, so it would be square root of 4, which is 2 over square root of 4 minus x squared dx. 2 is a number, I can take it out. And the integral of 1 over square root of 4 minus x squared is sine inverse x over 2. That's a formula. 2 is the square root of 4 from 0 to 2. So this would be 2 times sine inverse 2 over 2, that's 1, minus sine inverse 0 over 2, which is 0. Well, sine inverse 1 is pi over 2 if you use the calculator, and 2 times pi over 2 is pi, and this is the same result we got by using geometry. So we are sure now that the length of the curve, this formula works, and it gives you the length of the curve. Set up but do not evaluate an integral for the length of the curve. Okay, he is asking about setting up the integral. So we will not evaluate, we'll just set the integral up. So I have y, I need y prime. Y prime is 3x squared. Then I need 1 plus y prime squared. And this would be 1 plus 9x to the power 4. So L would be integral from 0 to 2 square root of 1 plus y prime square, which is 1 plus 9x to the power 4 dx, and that's the formula. That's the arc length. Here I have y, I need y prime. Y prime is 1 minus 1 over x, and 1 plus y prime square would be 1 plus 1 minus 1 over x to the power 2, and then L would be integral from 1 to 4 square root of 1 plus 1 minus 1 over x to the power 2 dx, and this is the answer. He said set up the integral, so that's the integral. Now here find the exact length of the curve. Well, exact length of the curve means arc length, okay? So I need to find y prime. Well, y prime is 3 over 2 times 2 over 3 x to the power 3 over 2 minus 1, which is half. Now y prime square would be, these cancels, will give you 1. X to the power half to the power 2, this would be x. So L, the arc length, would be integral from 0 to 2 square root of 1 plus y prime square, which is x squared dx. uh, sorry, y prime square is just x. Y prime square is just x. So that's the length of the arc, and the integral of square root of 1 plus x is easy. It is 1 plus x. We write it to the power half, and then we add 1 over 3 over 2, 2 over 3, and we find the integral from 0 to 2. Okay, please continue and find the answer. And remember that we can use this formula when we have ax plus b to the power n. You can say this is uh, the integral. It would be ax plus b to the power n plus 1 over n plus 1. Only if we have ax plus b, x is a linear function here, okay? And then we divide by the derivative of ax plus b, which is a. But here the derivative of x is 1, so that's fine. Well, here to find the arc length, x is from 2 to 3. So I need to solve this equation for y. I need y to be written as a function of x. So let me first find y squared by dividing x squared minus 4 to the power 3 by 36, okay, the number 36. And then y would be plus or minus square root, but he said y is positive, so we take the positive square roots. Square root of 36 is 6, and this would be x squared minus 4 to the power 3 over 2. It's to the power 3. When we raise it to the power half, or when we take the square root, it would be to the power 3 over 2. Well, y prime, we need y prime now. Y prime would be 3 over 2 times 1 over 6 of x squared minus 4 to the power 3 over 2 minus 1, which is half, times the derivative. Of course, this is a number 6. We can just take it out or leave it as it is. But now the derivative of this 3 over 2 times x squared minus 4 to the power half times, using chain rule, the derivative of x squared minus 4, which is 2x. And now 2 times 3 is 6. It will disappear, it will be cancelled with this 6. And y prime would be written as x times the square root of x squared minus 4 over 2. And now y prime square would be equal to x squared times square root of x minus 4. When you raise it to the power 2, it will disappear, the square roots. And now I need to find 1 plus y prime square. So I need to add 1 over 1 plus this fraction. And adding this fraction, I will get 4 times 1 is 4, and 4 times 1 also is 4, plus x squared times x squared, that's x to the power 4 minus 4x squared. And now if you notice, I have x to the power 4 minus 4x squared plus 4 in the numerator and 4 in the denominator. So when I find the square root of x to the power 4 minus 4x squared plus 4 over 4, I will have the square root of, now square root, I can distribute the square root. Square root of 4 would be 2. Square root of the numerator. Now in the numerator, I have 3 terms. And whenever you have 3 terms under the square root, and you can see that x to the power 4 has a square root, which is x squared, and the negative sign in the middle is negative, and 4 has a square root, which is 2. So I can write these 3 terms as a perfect square, like this, x squared minus 2 to the power 2. Okay, remember, a minus b all square is equal to a square minus 2ab plus b square. So the three terms can be written as a perfect square if the first term has a root, the last term has a root, and the midterm is the root of a square times the root of b square, a times b times 2. So actually the root of x to the power 4 is x squared, the root of 4 is 2. If you multiply 2 times x squared times 2, you get 4x squared, and the negative sign is there, of course. So you can take the square root, and this would be x squared minus 2 over 2. So this is the square root of 1 plus y prime squared. So L would be integral from 2 to 3 square root of 1 plus y prime square, which is this one, x squared minus 2 over 2 dx. And this is very easy. I can take the half out, and x squared, the integral is x cubed over 3, and the integral of 2 is 2x, and find the value of the integral. Replace x by 3 minus replace it by 2, and find the answer. So that is the arc length. So notice this idea that always you will need to do something like this, because finding the integral of square root of these three terms is not possible. We don't have a method. So it must be you must be able to write it as a perfect square. Always this case will uh, frequently appear in this section. Well, this is why I need y prime. So y prime would be 3 is just a number, keep it. So the derivative of x cubed is 3x squared. 1 over 4 is just a number, keep it. Now think about x. X is in the denominator, it has power 1. But if you take it up, then it would be x to the power negative 1. And what is the derivative of x to the power negative 1? It is negative 1 over x squared. So I can write it y prime, cancel 3 with 3, I have x squared, and here it would be negative 1 over 4x squared. Now I need y prime square. To find y prime square, I will square these two terms. And when you square two terms, the square of x squared is x to the power 4 minus 2 times x squared, the first term, times 1 over 4 x squared, the second term, plus the square of the second term, which is 1 over 16 x to the power 4. Now you can see that I have x to the power 4, and here x squared cancels with x squared, and negative 2 over 4 is just negative half, plus 1 over 16 x to the power 4. So think of this now. These three terms can be written as a perfect square like this, because now we need to find 1 plus y prime square. And when I add 1 to y prime square, which is x to the power 4 minus half plus 1 over 16x to the power 4, then I can write it x to the power 4. 1 minus half is positive half plus 1 over 16 x to the power 4. So these three terms are exactly the same like this one, but only the negative sign becomes positive, which means I can write it exactly like this. So I can write it as x squared, but instead of negative, it would be positive 1 over 4 x squared to the power 2. So 1 plus y prime square becomes a perfect square, and that's the general idea here. So now when you find the arc length from 1 to 2 of square root of 1 plus y prime square, 1 plus 1 plus y prime square is already, you wrote it as a perfect square. So the square root cancels with the perfect square, and you have x squared plus 1 over 4x squared, and you can find this integral easily. So the integral of x squared is x cubed over 3, and 1 over 4 is just a constant, forget about it. This is x squared, take it up, x to the power negative 2. Now find the integral, it would be x to the power negative 1. So I bring it down over negative 1. So find, uh, replace x by 2, then minus, replace x by 1, and find the answer. Let us find the answer for one time. So 2 to the power 3 is 8 over 3. Negative 1 over 4 times 2 is 8. So this is when we replaced x by 2. Minus, replace x by 1, 1 over 3. Minus 1 over 4 times 1 is 4. Use the calculator and write the final answer. Another question. Again, find the arc length. So we need to find y prime first. The derivative of 3 is 0. Half is a constant. Derivative of cos 2x is sinh 2x times the derivative of 2x, which is 2. This 2 will cancel with this 2. So L would be integral from 0 to 1 square root of 1 plus y prime square, and y prime square is sinh square 2x dx. Well, there is a formula in the hyper uh, hyperbolic function says that cos square of x minus sinh square of x equals 1 minus. Okay. So sinh square, if you take sinh square to the other side, 1 plus sinh square will give you cos square. So this is a formula to remember, and then you will be able to write this one as 1 plus sinh square would be cos square. But I have 2x here, so it's cos square 2x. And as usual, 1 plus y prime square, if you write it as a perfect square, then the square cancels with the square root, and you will have just cos 2x. And the integral of cos 2x is sinh 2x over 2 from 0 to 1. So the answer is sinh 2 minus sinh 0. Sinh 0 is 0. You can use the calculator over 2. Of course, in the calculator, you have hype, you have button for hype. If you ask for sinh 2, you will find it number digits. If you ask for sinh 0, it would be 0. So you can write the answer as sinh 2 over 2, the exact answer. Let me solve finally this exercise, and then I'll stop and continue in another video. And let me call this an additional exercise. Notice here that x is not given. It's not given that x between what and what. We need to find the arc length. But if you look to the function, I have x minus x squared below the square root. So x minus x squared has to be greater than or equal to 0. That's the domain of the function. And to solve this inequality, I have to find the zeros. So if you factor, then the zeros are 0 and 1. And now if you check these three regions, which one of them will give you a positive sign? So if you put x2, 2 minus 1, 2, this is positive. And, oh, sorry, this is not x minus 1. If I take x as a common factor, I will have 1 minus x. So if I put x2, 1 minus 2 is negative. So this region is not good. Negative 1, 1 minus negative 1 is positive, but there is a negative 1 here, so this is not good. If you take half, 1 minus half is positive times half positive. So the answer, the domain, x should be between 0 and 1. That's the domain. Also, if you look here, x is inside square root, so x has to be greater than or equal to 0. But also this square root of x is in the domain of sine inverse. And the domain of sine inverse is equal to the range of sine. And the range of sine says it's between 1 and negative 1. So x has to be also less than 1. Greater than 0, less than 1. So x has to be between 0 and 1. So he did not mention here in the question that x is between 0 and 1 because you can find it using this technique, using this information. You can find that x must be between 0 and 1. So let us find y prime. The derivative of the square root is 1 over 2 times the square root. Times the derivative of x minus x squared, which is 1 minus 2x. Plus the derivative of sine inverse, which is 1 over square root of 1 minus sine inverse x. I write here x squared. I have sine inverse square root of x, so this is square root of x all square. Times the derivative of the square root of x, chain rule, which is 1 over 2 square root of x. Now, I have 1 minus 2x over 2. If you notice, this is the square root of x times 1 minus x. If you factor x times 1 minus x. And here, this is also plus 1 over, I have 2 square root of x times square root of 1 minus x. So actually, this is also can be written as a square root of x times 1 times square root of 1 minus x because you can distribute the square root. So I have the same denominator, so I can add the numerators. So I have 1 minus 2x plus 1 over 2 square root of x times square root of 1 minus x. 1 plus 1 is 2. And I can take 2 as a common factor. 2 cancels with 2, and I have here 1 minus x to the power 1, and this is 1 minus x to the power half. So when I subtract the powers, I'll have 1 minus x to the power half in the numerator. So this is y prime after simplifying. And you need to simplify y prime before raising it to the power 2. Imagine you raise this to the power 2. Simplifying is very important. Okay, if you raise this to the power 2, then you will have 1 minus x over x. And now let us find 1 plus y prime square. This is the term inside the square roots in the formula of the arc length. And now I need to add these two fractions. So I have x plus 1 minus x. X cancels with x, and I just have 1 over x. So L would be, we said that x is from 0 to 1. Square root of 1 plus y prime square. So it's the square root of 1 over x dx. But square root of 1 is 1 over square root of x, and to find the integral you write it x to the power negative half, then you add 1, so it would be x to the power half over half or times 2 from 0 to 1. So the answer is 2 times 1 to the power half is 1 minus 0. So the answer is 2. The arc length is 2. I'll stop here and study well and hope the arc length is easy now for you.